Hey everyone, so now we are going to solve course schedule 2 from Leetcode. This has been asked a lot of time by many top tier companies. As you can see, a lot of time it has been asked. So I'll reset this guy. Okay, so yeah, there are total, let's zoom in a bit. Okay, there are a total of num courses you have to take labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites of ai indicates that you must take courses bi first if you want to take course ai. For example, the pair 0 1 indicates that to take course 0 you have to take course 1. Return the ordering of courses you should take to finish all courses. If there are many valid answer, return the ordering of course you should take to finish all courses. If there are many valid answers, return any of them. If it is impossible to finish all courses, return an empty array. Okay, so in the last in the course schedule 1, we have to just return true or false, but in this in this we have to return a pattern, like how you would be going solving all the mm, yeah, all the courses. So I guess topological sort would be the so I learned topological sort in course schedule, so I believe we can use the same principle, and just when we are popping the element from the queue which has 0 incoming edges to it, and then we can simply put it in the output variable and then log it out. So let me just, for this example too, I'll just write down, okay, let me just refresh this guy. And once this is set, I can just write down this 1 0 2 0 3 1 3 2. Okay, so I wrote down this. Let's go back here and see if we can, yeah. So this is the edges that are given to us. So here, for in order to take course 1, we have to, in order to take course 1, we have to do course 0. So what we'll do is in the last course schedule, we formed in degree array. So that here also it will be 0 to 1. So we have number of courses, how many number of courses were there? There were just 4 number of courses, right? So num courses are 4. So we'll form a in degree array of 0 0 0 0 0 0 1 2 3. All right, so once we've got that, then we have to create the adjacency list. Adjacency list would be, so we'll go by 0 0, and first of all we'll also create a graph out of it. So let's draw the graph. It will look like this: 0, and then first we have to do 0, then we can do 1. Okay, then first we have to do 0, then we can do 2. Okay, first we have to do 1, then we can do 3. So there is an out edge from 1 to 3. And first we have to do 2, then we can do 3. So this is the whole, this is the graph, and for that adjacency list would look like C for 0, 1, and 2. You have to first do 0, then you can do 1 and 2. Then you have to, then we'll check 1. In 1, you have to do 1, then you can do 3. Then for 2, you have to do 2, then you can take the course 3. For 3, 3 has no other dependencies. There's no course that is dependent on 3. So for 1 and 2, you have to do 0. For 3, you have to do 1. And uh, for again 3, you have to do 2. So I hope this makes sense. Yeah. So once we have our adjacency list ready, we can what we can do is have an array, a result array here, which will store everything. So we'll check for check the values where in degree is 0. So while we are updating this adjacency list, we can also update the in degree. So in degree meaning, as if you can see here, 0 has a no incoming, so it will remain 0. So 1 has incoming as 1, so we'll update it to 1, and you can see that 2 has one incoming node, one incoming edge. So we can update that here with 1, and we can see that 3 has two incoming edges, so we can update its value to 2. So yeah, so this is the incoming edge. So what, and there is our queue. So what queue is looking for is, or I'll draw in the simple way which we are. So what queue is looking for is, it's looking for in degrees nodes which are having 0 edges, so 0 incoming edges. So at this moment only 0 has it, so we have to loop through the entire in degree to find out which all nodes have 0 in degrees, and in this case only 0 is there, so we put it into the queue. Then we run a while loop while queue dot length is not null. Then we have to, every time we have to shift, like remove the first node from the element and visit its all neighboring neighbors, and um, decrement the in degree of the neighbors. And yeah, so we pop this out. So we pop this out and we decrement. So as you can see here, it's dependent courses are 1 and 2. So we decrement one's value and it becomes 0. And as soon as it becomes 0, we append it to the queue, and we also do it for 2. So 2 also gets added because it also becomes 0. Then we visit 1, then 1 is 3, then we decrement this 1, then there is nothing to traverse in the 1, then 2 is shifted, then 2 has neighboring 3, then we again decrement, which becomes 0, then 3, then 3 is shifted, and 3 has nothing to be visited. So that is our result. But my concern is, how can we find a cycle in this? So in the last course schedule, if um, number of visited nodes is less than the number of courses, then the cycle was available, right? Okay, so we can check that if, okay, the output the result should be always equal to the number of courses. So result length is not equal to the equal to the um, number of courses. Then we can say that it's there is a cycle present. Or okay, so okay, and then questions. All pairs are distinct. We should always ask a question like clarifying questions that I just straight away jumped onto the um, to solve it. So I need to make sure that I always ask questions. All the pairs are distinct, then AI is not equal to BI. Okay, but what about the cycle? How can we detect a cycle? And always we'll be able to get to the result. Will there be any cycle in this? Okay, let's figure it out. Let's try to code it up. So we'll do the adjacency list. It is similar to the last one. And then once we have done this, let int degree is equal to new array num courses dot fill 0. Okay, once we have that, then what we have to do is for let I is equal to 0, I is less than num courses I plus plus. If then adjacency list, what we have to do is dot set for I, we have to set an empty list here so that you can store the dependent courses in it. So we have to now loop through I. We can restructure the course and redirect here of prerequisites. So once we have got that, then we can simply call the adjacency list dot get for prereq, because we are storing prereqs dependent courses in that, and then simply put course and update the integrity of that particular course, because from prereq there will be a edge going, like edge going to course, a directed edge going to the course. So course plus plus. So once we have done that, we can come and we have to also specify let result is equal to an empty array. So in the end we can simply write, we have to also have a let q is equal to empty, and then for let I is equal to 0, I is less than in degree dot length I plus plus, then q. So if in degree of I equal to 0, then we can simply q dot push that node in the queue. So yeah, we have pushed that node into the queue. Now we can loop through q dot length, and then let node is equal to q dot shift. We shift that from the take the first element out of the queue. Then what we do is we result dot push that that node into the result, because that's the first thing that what we have to do. And then what we have to do is loop through the dependent courses. Let course of adjacency list dot get the node. Once we get that, then we have to decrement the value in the integrity course minus minus. If integrity equal to 0, then we have to push it into the queue. In degree of course is, then that course will be pushed, and yeah, that's about it. So here return result dot length should equal to num courses, right? Oh, you have to simply return result dot length and num course is equal to 1, and prerequisite num courses prerequisite less than prerequisite is greater than equal to 0 and less than So there is a edge case if prerequisites prerequisites dot length equal to 0, then return result. Sorry, we have to return an array, right? Okay. Okay. So yeah. So 33 cases, test cases passed, and 40 out of 45. So 0 and 1, 2 and 1. So what test case failed? I'll write it down in. Okay, so this test case failed, right? 1 0, 1 2, and 0 1. Okay, let's see it on our uh, white blackboard. Okay, so what? So from 0 there is an edge to 1, then there is an edge from 2 to 1. So you have to do 2, and there is an for doing 1 from, and there is an edge 1 to 0. So there is a cycle here. So how are you detecting a cycle in this guy? As you can see, there is a cycle here. Then in course schedule 2, if we minimize this, let's see. Okay, let's look through this. It's in degree 0 1 2. In degree, if we see, there is 1 here, 2 here, and 0 here. So obviously adjacency list, if we see 0 1 2, what adjacency list would be? 1 0 and 1. So first of all, we'll visit the queue. Will have 2 in it, and then we'll take 2, search its dependents. So one is there. We'll remove 2, and then we'll add 1, and we'll also decrement the count of in degree in 1. We can add 1, right? Because okay, once we do this, 2, we cannot visit all nodes because this is a cycle. So in here, if we are not able to visit, here we can check if result.length is not equal to num courses, then we can return an empty. So if we bring up that console and then take the prerequisite test cases, add them here, then update this and run this, then this should work. Yeah, got it. And if we submit, okay, yeah. So we did this. Yeah, this is not required. This guy, and I last submitted it in March. Let's see. So it was a good investment to study about. Okay, I did it in with the TFS, but topological sort is also intuitive in course schedule. In DFS, it's always other way around. So let's see how I did it. Let's visit it. Fill false, new map, um, num courses, visits. So we do it other way around. Okay. So if it returns false, okay, or result. So function DFS, we are storing result, cycle, course. So, okay, if cycle course, if we are visiting it, okay, true, visited course, true, okay, course, okay, yeah, but I guess topological sort is also pretty much intuitive, and this is a good question to go through. This is also listed in the Leetcode practice. So this is what I'm solving. I can take this, check mark this. Okay. The, the, okay. I hope I can review this later, sometime later, and understand it. I hope the explanation was a bit understandable, and not here and there. I'll try to improve my explanation because it's the important part to get your thoughts to the interviewer in the interview. So yeah, this is it, guys.